हेलो फ्रेंड्स, वेलकम टू माय चैनल। मैं हूं आपका दोस्त महेश कुमार। फ्रेंड्स, आई स्टार्ट करते हैं दिस न्यूमेरिकल क्वेश्चन रिलेटेड टू बेल कोलमैन साइकिल और रिवर्स ब्रिटन साइकिल और रिवर्स जूल साइकिल। फ्रेंड्स, question is, in an open type of refrigerating installation. Friends, open type of refrigeration means it is talking about Bell Coleman cycle or reverse Britten cycle or Joule cycle. Getting friends? So 1000 kg of atmospheric air are circulated per hour. Okay. The air is drawn from the cold chamber at temperature 7 degrees centigrade and 1 bar, and then compressed isentropically to 5 bar. It is cooled at this pressure to 27 degrees centigrade and then led to the expansion where it expands isentropically down to atmospheric pressure and is discharged to cold chamber. Find the followings. Okay, find the followings. First, heat extracted from cold chamber per hour, heat rejected to cooling water per hour, COP of the system. Take for air gamma equal to 1.4 and specific heat at constant pressure equal to 1 kilojoule per kg degree centigrade. Getting friends? So this is the question. Let's understand the question first. Okay, getting friends? So first understand, this is the Bell Coleman cycle or reverse Britten cycle or reversed Joule cycle. Getting friends? In this, one compressor is there, cooler is there, expander is there, and refrigerator is there. Okay, so whatever refrigerant is there, it will pass through the compressor, then it will cool, or heat rejection is there in the cooler, then it will pass to the expander, and then it will pass to the evaporator where heat absorption will be there. So this is the TS diagram. 1 to 2 is the compressor which is following, or we can say it follow isentropic process. Okay, isentropic process means Pb to the power gamma is equal to constant. Okay, then at constant pressure the heat rejection is there. So here constant pressure Q rejection is there. Then in process 3 to 4 it is in the expander and it will also follow the isentropic process Pb to the power gamma is equal to constant, and again at constant pressure refrigeration take place where it will take heat or absorb heat from the system. Okay, now what data has given here, what data has given here, given data is total mass equal to 1000 kg per hour. 1000 kg of atmospheric air are circulated per hour. Okay, mass equal to 1000 kg per hour. The air is drawn from the cold chamber at temperature 7 degrees centigrade. So T1 equal to 7 degrees centigrade. So absolute temperature T1 equal to 273 plus 7 is equal to 280 Kelvin. Okay, and 1 bar. So pressure equal to P1 equal to 1 bar, and then compressed isentropically to 5 bar. Friends, it is saying that here you just see the air is drawn from the cold chamber. The air is drawn from the cold chamber at temperature 7 degrees centigrade in 1 bar pressure. Friends, this is the cold chamber where the heat absorption will be there or heat extraction will be there. यहाँ पे क्या करेगा फ्रेंड्स, इन प्रोसेस 4 to 1 में यह हीट एब्जॉर्ब करेगा और हीट एक्सट्रैक्ट करेगा फ्रॉम द सिस्टम. So at the end of this process, it is saying that the air is drawn from the cold chamber at temperature 7 degrees centigrade and pressure 1 bar. So it is saying that it is at this temperature, at this point, temperature is equal to 280 Kelvin. We will convert the temperature in the Kelvin. Okay, getting friends? Then, and this pressure, this P1 pressure, P1 and equal to P4 pressure is equal to 1 bar. Now what it is saying, it is saying that this liquid or this air is compressed isentropically to this pressure, P2 pressure. Okay, it is then compressed isentropically to 5 bar. Okay, it is cooled at this pressure to 27 degrees centigrade and led to the expansion where it expand isentropically. Friends, it is saying that first it has compressed from point 1 to point 2. So this pressure is equal to 5 bar. P2 is equal to P3 is equal to 5 bar. And then from here it started cooling, and then here it is cooled this pressure to 27 degrees centigrade. So up to 27 degrees centigrade it has cooled. It means the temperature T3 equal to temperature T3 equal to 27 degrees centigrade plus 273 equal to 300 Kelvin. So this temperature has given and this temperature has given, and the pressure, this pressure has given 1 bar and this pressure has given 5 bar. Okay, this much clear. Now what other data has given? What other data has given, friends? Here you see, take for air gamma equal to 1.4 and Cp equal to 1 kilojoule per kg degree centigrade. So gamma equal to 1.4 and Cp equal to 1 kilojoule per kg degree centigrade, or it should be, I think, Kelvin. Okay. Friends, here 1 kilojoule per kg, it should be in Kelvin. Don't be confused, it should be in Kelvin. So here also we will take Kelvin. Okay, because this temperature is in Kelvin, so this also will be in the Kelvin. Okay, now friends, now we will find all temperature, like here temperature at this point T2 we will find, T4 we will find. Why? Because if you are able to find this temperature, then problem will be easily solved. Okay, so first what we will do, friends, we will try to find all temperature 1, 2, 3 and 4. at all temperature points 1, 2, 3 and 4 we will find the temperature. Okay, so friends, from process process 1 to 2, process 1 to 2 is what? Isentropic process. Isentropic process, because it has given isentropically. Okay, and expand also isentropically. So in both case it will follow pb to the power gamma is equal to constant, and here also pb to the power gamma is equal to constant, or it is isentropic process. Okay, now here friends, P2 upon P1, this temperature T2 upon temperature T1 equal to P2 upon P1 to the power gamma minus 1 upon gamma. This is the relation when the process is isentropic. Okay, so process 1 to 2 is isentropic process, so it will follow this relation, temperature at, or you can say T2 upon T1 equal to P2 upon P1 to the power gamma minus 1 upon gamma from thermodynamic relation. Okay, so here you see friends, T2 we don't know, T1 the value has given, P2 pressure P2 value has given, and pressure P1 value has given. So we will find the temperature T2. Okay, so P2 equal to how much? 5 bar, 5 bar divided by 1 bar. So unit is same, bar and bar, so it will cancel out, and here gamma value is equal to how much? 1.4 minus 1 divided by 1.4. Okay, so friends, how much value we will get here? How much value we will get? 5 to the power 1.4 minus 1 divided by 1.4. So it will come 1.5838. Okay, this is the T2 upon T1 temperature. How much? T1 temperature is equal to 280. So 280 Kelvin. So T2 is equal to how much friends? T2 equal to, multiply with 280, so it will give friends 443.469 Kelvin. Okay, so this temperature is equal to what? This temperature is equal to 443.469 Kelvin. Okay, now we will find the temperature this point. Same procedure will follow because it is isentropic process. So what we will do, from process 3 to 4, process 3 to 4 is, it is also isentropic process. So T3 divided by T4 equal to P3 divided by P4 to the power gamma minus 1 upon gamma. Okay, and here you see friends, P3 is also 5 bar and P4 is equal to 1 bar. So here 5 divided by 1 to the power 1.4 minus 1 divided by 1.4. So same here, same value will come. So 1.5838, and we know that friends, here the temperature equal to T3 temperature is equal to 300. Okay, T3 temperature is equal to 300. So 300 divided by T4 equal to 1.5838. So T4 equal to how much it will come? 300 divided by cross multiplication we will do. So T4 equal to how much? 300 divided by 1.5838. So it will come approx 189.417 Kelvin. Okay, getting friends? So here that T4 temperature is equal to how much? 189.417 Kelvin. So we are able to calculate all the temperature at 1, 2, 3, 4 point. Okay. Now friends, now we will find what it is asking. It is asking that heat extracted from cold chamber per hour, heat rejected to cooling water per hour. So heat extracted, it means this process is in the refrigerator. Heat rejected means this process is in the cooler. Okay. So what we have to find? Heat extracted. Heat extracted QA equal to heat extracted means heat absorbed. QA equal to how much? MC into temperature at T1 minus temperature at T4. Okay, because we know that enthalpy at zero point 0.1 minus enthalpy at 0.4, it will give the heat extraction. Okay, and enthalpy equal to what? C into T, Cp into T. Okay, so here mass is equal to how much per hour? Mass is equal to 1000 kg per hour. Cp is equal to, this is Cp equal to 1 and T1 equal to 280. T1 is equal to 280 Kelvin minus T4 is equal to 189.417. Okay, so friends, it will give how much? This 189.41, 280 minus this value, so 280 minus answer, and we can multiply with 1000. So it will give friends 9058.2.144 kilojoule per hour. Okay, so this is the heat extracted. Getting friends? This is the heat extracted because it is asking in per hour. Okay. Now the second point is that heat ejected to the cooling water per hour. This also per hour is there. So we will find this one also. Heat rejected means you have to follow this process 0.2 to 0.3. So in this friends, what happened? Heat rejected equal to same M into Cp into T2 minus T3, or this enthalpy 2 minus enthalpy at 0.3. Similarly here, this is 1000 into 1 into T2 value, how much? 443.469 minus 469 minus T3 is equal to 300 Kelvin. T2 value is equal to this one, T3 value is equal to 300. So how much it will come friends? How much it will come? This 443.469 minus 300, so it will give 143 into 1000. So it will give friends 143,469 kilojoule per hour. Okay, this is the heat rejected. Getting friends? This is the B part. Now what is the C part? C is the coefficient of performance of the system. Okay, coefficient of performance of the system, COP. We know that friends, COP equal to heat absorbed upon what happened? Work input. Heat absorbed upon work input. Okay, friends, since here both process means process 1 to 2 and 3 to 4. This 1 to 2 and 3 to 4 is isentropic process. Okay, and Pb to the power gamma is equal to constant. So in this case, work input equal to heat rejected minus heat absorbed. Okay, so in this case, when isentropic process follow, or we can say process follow isentropic process, then in this case work input is equal to heat rejected minus heat absorbed. So what happened? This value upon heat rejected minus heat absorbed. So we know that friends, heat rejected is equal to, sorry, this is the heat absorbed. Heat absorbed is equal to how much? 9058.2.144 divided by heat rejected is equal to how much? 143469 minus heat rejected this one, heat absorbed this one, 90582.144. How much this value is there? Minus 9058.2.144. This value will come and we will divide. What we will do? We will divide this one, COP equal to this 9058.2.144 divide by how much? 528 52886.85. So friends, it will give how much? 9058.2.144 divided by answer. So friends, it will come 1.712. So COP value will come 1.712. Getting friends? Since just understand the concept here, since the process is isentropic, so in this case we can take work input is equal to heat rejected minus heat absorbed. Friends, what happen if it is follow Pb to the power 1.2, okay, is equal to constant. So it is not the isentropic process. So in this case we have to find work input based on this one, this value. Okay, getting friends? Then we can divide, then we can get the value of COP. Okay, why? Because friends, see here, if it is isentropic process, then what happen? Isentropic process, Pb to the power gamma is equal to constant. So in this case heat transfer is equal to 0. In thermodynamics we understand that heat transfer equal to 0 by this process. But if it is polytropic process like this, Pb to the power n is equal to constant. So in this case heat transfer is not equal to 0. It means what happened? Some heat transfer is there to the surrounding. Okay, getting friends? But in isentropic process heat transfer is 0 to the surrounding or from surrounding to the system. But in polytropic process heat transfer is not equal to 0, means some heat transfer will be there. So in this case that we have to find work input based on the given index. ओके फ्रेंड्स। सो फ्रेंड्स, मेरा एक्सप्लेनेशन आपको अच्छा लगे तो प्लीज़ लाइक कीजिए, कमेंट कीजिए, मेरे चैनल को सब्सक्राइब कीजिए फ्रेंड्स। किसी भी पॉइंट पर आपको डाउट हो फ्रेंड्स, आप मुझे कमेंट बॉक्स में पूछ सकते हैं। मैं इसको फिर से एक्सप्लेन करने की पूरी कोशिश करूँगा। थैंक यू फ्रेंड्स।